Alright, number 23, we want to solve by factoring. So we have x squared minus 5x plus 4 equals 0. So factors of 1 times 4, 1 and 4, 2 and 2. We want to add to get 5, so that would be 1 and 4. So it will factor, right, 2 sets of parentheses, split up the x squared, the numbers 1 and 4. First sign is your larger number, second sign tells me they're the same. So when I set these equal to 0, I would get x equals 1 and x equals 4, both positive. So positive 1 and 4, answer choice B. Here, number 24, we want to use the intermediate value theorem to determine whether the polynomial function has a 0 in the given interval. So what we're going to do is we're going to do synthetic division. I think that's better than plugging it in. So intermediate value theorem just says we're going to use these two values. So it's kind of like saying f of, it's kind of like finding f of, like if you plug it in -2, which I think is harder, and if you plug in f of -1. So if the y value is positive here and negative here, or vice versa, if it's negative and positive, we know at some point the graph had to cross the x-axis. Like if you get a negative y value and then a positive y value between those two, at some point it had to cross 0 to go from negative to positive, or vice versa. So I'm going to do it with synthetic. I think that's easier to do it. So I'm going to do -2 first. We have x to the 5th, so 3 is a coefficient. We do not have an x to the 4th, so I need a 0 as a placeholder. And then we have -3 to the 3rd, and then -7 squared. We do not have a single x, so 0, and then a positive 8. So I'm going to do this one first. I'm going to drop down this 3, multiply, give me a -6, combine -6, multiply, give me a positive 12, combine, give me a positive 9, multiply, give me -18, combine, give me a -25, multiply, give me a positive 50, combine, still positive 50, multiply, give me a -100, and combine, give me -92. So we get a -92 here. So f of -2 would be a -92. We get a negative value. So now I'm going to do it with -1. Same values, 3, 0, -3, -7, 0, and 8. I'm going to bring down the 3, multiply -3, -3, multiply, give me positive 3, 0, 0, and -7, positive 7, and positive 7, -7, positive 1. Okay, so we can see that we went from a negative to a positive. So intermediate value theorem says that yes, we get a 0 between those two. -92 and positive 1, -92, positive 1, yes. So answer choice B. We're going to find the exact value of this expression. So, I guess you can do it one of two ways. This is 25. So you can do this one of two ways. Log base 10 of 1000 equals x. You can actually plug this in your calculator because it has base 10. It'll give you the answer. Or you can write it as exponential form, and you can say 1000 equals 10 to the x power, and you can rewrite this. This would be 10 to the third power. Okay, but since log has base 10, if I just plug it in my calculator exactly like that, go second quit, log of 1000, you will see 3 as your answer. And same thing we're getting here. We're getting 3. So answer choice 3 would be best. And then number 26 wants us to do the difference quotient. Those are always fun. We're going to find the difference quotient. So we have f of x is 2x squared. Alright, so the difference quotient, they're giving it to us. So we're going to do x plus h in the place of x. So the first part, where it says f of x plus h, we're going to plug x plus h in the place of x. So that would be, the first part would be 2x plus h squared. And then minus f of x, which this is f of x, so minus 2x squared. And then all divided by h. Alright, so now from here we're going to actually FOIL this out. So the top part, I'm going to leave the 2 on the outside. And that's going to give me x squared. And then 2xh, because we have x plus h twice. You multiply those and double it. So plus 2xh. And then you square that, so plus h squared minus 2x squared, all divided by h. Alright, now I'm going to distribute 2 throughout these parentheses. So on my numerator I get 2x squared plus 4xh plus 2h squared minus 2x squared over h. So on the top, minus 2x squared plus 2x squared will cancel out, and we're left with 4xh plus 2h squared. And from this point, we can factor an h out of both of those. So if we do that, we would have an h out here. That would leave me with 4x plus 2h over h. And now that h and h will cancel out. And then from here, we can factor out a 2. And so that would give me a 2 on the outside, and then 2x plus h. That's all the way simplified, all the way down. So the 2 and then the 2xh looks like answer choice C. Because you got to simplify all the way.